For 1A, we're given that AC is congruent to DC. It's already marked, but we'll just mark it again to get in the habit. We also see that B is the midpoint of AD. So by the definition of a midpoint, we know that DB is congruent to AB. Next, we look to see if there's anything else that we can prove congruent, which there is. CB is congruent to itself, CB, by the reflexive property. For every new pair of congruent sides, we add a little tick mark to denote it's a new pair of congruents. Next, we look to see, can we prove that these two triangles are congruent, which we can, by the side-side-side congruence theorem, where we have that triangle ABC is congruent to triangle DBC. Next, B. We're given that FD is congruent to BC, so we mark that on our triangles. Next, we're given that ED is congruent to AC. And then we have that angle F and angle B are right angles. If this was a congruence proof, we could say, because of the fact that they're right angles, they are congruent, because all right angles are congruent. But it doesn't ask us yet for that. Instead, we can see that normally this would look like angle side-side, which is never a congruence theorem, and we can never use that to prove congruence between triangles. However, there is another congruence theorem we can use, which is HL. We use that when we have a right angle and the side opposite of the right angle, the hypotenuse, is one of the congruent sides. And the L for leg is another side on the triangle, which is congruent to a corresponding side on another triangle. So these two triangles are congruent using HL. So we can say triangle ABC is congruent to triangle EFD. Next, we have C. We're given that angle B is congruent to angle D, so we mark that. Next, A is the midpoint of BD, so by the definition of a midpoint, we know that BA is congruent to DA. Also, we have this bow tie shape, so we know that there are vertical angles that are congruent. So we mark our vertical angles. BAC is congruent to angle DAE. Next, we can say that we have enough information to prove congruent triangles. It is angle, side, angle, because this side is included between the two angles that are congruent to corresponding angles on the other triangle. So by angle, side, angle, we know that triangle ABC is congruent to triangle ADE. Next, on D, we have that AC is congruent to DC. We also have that angle A is congruent to angle D. We next look to see if we have anything else we can prove congruent, which we do, which is CB is congruent to itself, CB, by the reflexive property. However, this is angle side side, which is not a congruence theorem, so we cannot prove that they are congruent. If we ever circle that they're not congruent, we cannot write anything in this blank following triangle ABC congruent. Otherwise, we would be conflicting ourselves with the two statements. So make sure that if you ever circle this, that we can't prove that two triangles are congruent, leave this blank. Next, we have that AB bisects DAC, angle DAC. Whenever we bisect an angle, we are breaking it up into two congruent angles. So I have that angle DAB is congruent to CAB. Next, we have that DB is congruent to CB. Now we ask ourselves, is there anything else we can prove congruent? Which there is. AB is congruent to itself, AB, due to the reflexive property. So we have, once again, angle side side, which is not a congruence theorem. So we can't prove congruence. Like before, we have to leave this blank. Next, we have triangle ABC we're looking at, and we're given that DA is parallel to BC. DA is parallel to BC. We can make this Z shape, and then we know that the angles inside the Z are congruent to each other due to alternate interior angles theorem. Next, we're given that DB is congruent to AC. Lastly, we ask ourselves, is there anything else we can prove congruent? Which there is. We can prove that BA is congruent to itself, BA, by the reflexive property. And now to see if we have enough information to prove congruent triangles, once again we have angle, side, side. So nope, we can't prove congruence.